Guys. Today we're going to discuss RAG applications, specifically a new application called Dragin, which Dragin is basically a framework in which builds upon RAG applications where dynamically we try to figure out where we will retrieve information from an external source. Traditionally, RAG applications use a vector database and use embeddings in order to basically extract out similarity between a particular token in a sequence. But a dragon would specifically look what particular token would be more relevant to that given the context that are specific. This kind of understanding the temporal dependencies located within a particular piece of text, audio, or video is extremely important if we want to extract out semantically relevant information that relates back to what the problem we're trying to solve. So today we're looking, as I stated, the paper Dragon that was put out by Su et al. From the Department of Computer Science at Xinjiang University and at Beijing Institute of Technology, which they basically integrated dynamic retrieval augmentation and tried to identify how they can dynamically retrieve information rather than just giving information at a single query. Basically, the way that it was broken down is they specified multi-round retrieval rather than just single round, and used a mechanism by which to query the particular database dependent upon the actual tokens that are relevant in that particular sequence or particular task. Specifically, they developed a mechanism called RIND, or real-time information needs detection, which basically assesses the uncertainty about its own content and then develops a mechanism by which it can extract and basically form different kinds of queries that would be able to access the context that is dependent within this particular piece of text or video or audio. They term this QFS, or query formation, based on self-attention. Using this mechanism, they were capable of demonstrating dynamic retrieval of information. Furthermore, this mechanism of RIND, real information detection, it was capable of extracting out context that was dependent on the actual tokens within the vector database. So as we can see in the figure, Einstein was born in the German Empire and moved to Switzerland in 1895. The statement University of Zurich is applied using self-attention, and that is itself being used to look up the particular relevant token inside of the query. This external knowledge is therefore allowed to be retrieved and therefore would be more dynamic rather than just using an embedding to retrieve a specific framework. By dynamically retrieving information according to self-attention, the QFS mechanism is capable of generating context that can aid in searching for relevant external knowledge. This improvement and innovation will definitely lead to further enhancement of context dependencies across large corpora of text. The kind of obstacle with these LLMs is the context specificity across a particular section. This series of abstractions within a particular text requires more context dependencies than can be presently extracted only through attention. So therefore, mechanisms such as Dragin can help enhance and can broaden our understanding of different types of higher order abstractions that can be extracted from a particular passage of text or other multimodal data such as video or audio. As I stated, that these obstacles that we have within LLMs currently is the context window. And not only is it the context window, but it's the ability to extract out higher order abstractions. Higher order abstractions are things such as causality, agency, intentionality, correlation, Things that we take for granted when we assess a particular situation that these models are not really doing. Autoregressive models in general are only predicting words based upon a probability matrix of what would be the most likely token or word that would appear in the next order in that sequence. These are a very low bar in terms of predictive potential. There are a lot of higher order and deeper levels of connections between concepts that exist within the world than just being able to predict what may follow temporally in a specific order. This ordinal regressive technique is self limiting in a lot of LLMs. Therefore, the ability to form hypergraphs of reasoning and being able to connect different concepts is the direction that AI has to go forward in order to mold and create a philosophical worldview of the world as a means to guide and as a means to build out higher order reasoning capability. S Mechanisms such as Dragin, they basically are using the regressive capability, but trying to make that more in a higher dimensional plane. I say in a higher dimensional plane because you can think of these concepts as existing on some type of planal surface. And all of the different connections that these things have with each other existing outside of this surface. You can imagine that we are like aliens basically on the lunar surface, and we're trying to view the world outside of us. And this world is the fabric of reality, it is the constellations that mold the world, and we're not able to see beyond the surface, the regressive surface in which we are peering over. Our small focal knowledge consists of the same perspective as an individual that sits looking out at the horizon. And that horizon needs to be widened. It needs to be widened by looking beyond this regressive technology. That horizon can be expanded. And when I say this, I say it emphatically. The main limitation of our knowledge is what we know. And whether or not we accept what we do not understand, then we can finally come to a realization that our perspective can only grow according to what we have consumed. The ability to form these higher order abstractions is necessary in order to therefore imagine. Think of it like this: a creature can only observe what it understands in its own language. We need to imagine a new language that doesn't exist in order to create and assess the parameters that are necessary to understand the world that we presently can't.